Good morning, everybody. Today we're on problem 2.4, factoring quadratics. So this is something you've learned in the past. Now we're taking it through the applications. I understand the way some of the questions are worded can be confusing at sometimes, so I'm doing my best to break it down. This will look a lot like the beginning and end of problem 2.4, so that, here we go. You guys can go through it with hopefully no issues. So I got a square here, and I purposely chose 12. In the book, I think they used a perfect square like 9 or 16. I forgot exactly, but you'll see why I did this. What is going on? So, well, we know that we got x squared here because x times x is x squared, and I purposely chose 12 to follow with these questions, which looks similar to what you're going to see today in 2.4. Now, we know that this times this equals 12. So I could have a couple different numbers here. I could have 2 here or 6 here. Or I could have 3 here or 4 here. And it doesn't make a difference which one you put where. I could put 3 here, 4 here, or here. It doesn't make a difference. It still multiplies to 12. So I'll do this a couple different ways. All right, so I'm going to just say, let's say I call this 6. All right, I'm going to call this 2, then this is going to be 6 times x, which is 6x, and x times 2, which is 2x. So that would be this. If I were to find out now I want to represent this as what's the area of the square. Well, the area is x squared plus 8x plus 12, okay? That's if you just happen to choose these as the factors. Now, let's say I instead chose 3 and 4. Okay? Let's say I chose 3 and 4. So, 3 here, 4 here still makes this multiply to 12. Well, now this is going to be 3x. This is going to be 4x. So now my area is going to be x squared plus 7x plus 12. Okay? And that's hopefully making some connections for you guys with what we did before spring break with all this stuff, just straight math. Now we're doing applications. So now I'm assuming there's going to be a little confusion just because we just did this, and now this looks just like some questions in today's problem 2.4. So this says consider x squared plus bx plus 12. Now I did these examples here so you see what happened here. Our middle term b of x changed whenever our factors change, but our constant, our c, always stayed the same. What multiplies to 12 that adds to b of x? What multiplies to 12 that adds to 8? Well, 6 plus 2, 6 times 2. What multiplies to 12 that adds to 7? Again, 3 times 4, 3 plus 4 is 7. So, knowing that, it says choose values for b so that you can factor. And this right here looks like this, okay? So I chose b as a factor of 8. So this way, this factors now into x plus 3, x plus 4, okay? So now I can factor, I'm sorry, I made a mistake, not on purpose. The first one I did was 2 and 6. So this again simplifies to, or expands, expanded form into x squared plus 8x plus 12. And now it says choose another value, and that's why I did this model for you so you guys know exactly what you guys have to do. So now, again, so I can factor. So now this factors into x plus 3, x plus 4 equals x squared plus 7x plus 12. Because remember, this times this, 4x, 3x makes 7x, this times this. Now there is another factor that you guys could also see. I know that 12 times 1 is also a factor that multiplies to 12. So that's going to change our b. So you could have chosen that one as well. X plus 12 times x plus 1 equals x squared plus 1 plus 12 is 13x plus 12. So these are all possible answers that I could have chosen to put in place here, but I'm hoping that this kind of jives now and makes a little sense. And then down here, we got some stuff that you'll see throughout today's work of just factoring quadratics. So I'm going to go through this with you. Again, you're asking yourself, what multiplies to 9 that adds to 8. Now, I made another mistake here because nothing multiplies to 9 and adds to 8. So let's change this to 10. All right, I meant to do that. That was my mistake. So if that's the case, I know x plus 1 times x plus 9. This multiplies to 9, and this also adds to 10. Now, in today's work, you're going to see a lot of negative numbers, so you got to be aware of what you make negative, what you make positive, being aware of that. So over here, I know, well, what multiplies to negative 18? Well, negative 2 times 9, which adds to negative 7, so that's not going to work out. I know that 6 times 3 is 18, so I'm going to do negative 6 and positive 3 because negative 6 plus 3 is negative 3. So that's why I said you got to be careful about which you make positive, which you make negative, because that has a really big fact on this middle term, plays a big role in this, because I know that negative 6 plus 3 is negative 3, and negative 6 times 3 is negative 18. Again, for the multiplication, it doesn't matter which one's negative, but for the addition, it really does. Over here, I've got a positive product, and I have a negative middle term, a b. That means that both my factors have to be minus. So this is x minus. Well, I know that 4 times 4 is 16, but that does not add to negative 10. I know that negative 8 and negative 2 will work for this. Hoping that today's work will make a lot of sense for you guys. You'll see everything that's going to be on Google Classroom, and then I'll see you guys at 1 o'clock for any questions you might have, and I will help you out. I will see you then. Oh yeah, remember this? Muy importante.